Welcome to Team 2021. Jira Service Management users know that they have the most powerful ITSM platform on the market today. ISO's Technology is an Atlassian Platinum Solution Partner with the experience and knowledge you need to make your JSM experience seamless and successful. We can help you create a more collaborative environment for your teams and improve the connection and communication between customers and your teams. Your teams can work smarter, faster, and better with Jira Service Management. ISO's Technology can take you there. Visit isostech.com/2021 to learn more.
Change is the way work gets done, the way we move forward, the constant in our lives. But for those working in software, it's that little bit more constant. I'm Chris. I'm a principal engineer at Atlassian in the beautiful city of Sydney. It's here that I've been spending my days, literally, thinking about how to make software changes safer. Today, I'm going to share some powerful new features in Jira Service Management with you that will change the way you think about software changes. We believe every company is becoming a software company. Software plays such a huge part of our lives now. Customers expect regular improvements and new features to be introduced seamlessly. They expect great performance and they expect rock-solid reliability. Organizations need to deliver on these or be outpaced by faster, more agile competitors, better placed to meet customer needs. To many of you, this is not news. In fact, you've probably already adopted CI/CD practices and may well have adopted DevOps principles, microservice architectures, and more to help accelerate your rate of change. But delivering changes quickly requires delivering changes safely, and that's where we'll focus today. Let's first talk about the acceleration of change. I'm on the Jira Service Management team, and I'll use Jira Cloud as a case study. I've mapped here the frequency of changes to Jira over time. If we go all the way back to 2008, where we saw the first Jira Cloud offering, Jira Studio, customers would receive new changes only about once per quarter. In 2012, we released Jira On Demand. This allowed us to deliver changes in a more fine-grained manner, but we'd only deploy changes every other week. Then in 2017, we migrated to AWS in an initiative called Project Vertigo, and you could read more about that on our developer blog. A monolithic Jira service gets deployed at this stage every 2 to 3 days. By continuously investing in this process, including introducing ways to make changes safer, we were able to reach 2 deployments of the Jira service by 2019 each day. Now, fast forward to today, our teams are collectively operating a huge number of microservices, and we make hundreds of deployments to production every day. Our rate of change has increased 1,000-fold in the last 4 years alone. Today, I want to share some key ideas that we've used to achieve faster and safer changes so that you might incorporate learnings from our journey into your own change processes. Today, I'll share 3 tips to make your software changes safer. First, I want you to think of software as a complex, interconnected system and show you ways to use services to tame complexity and reduce change risk. Second, I want to share the value of having a single system recording every change and show you how you can connect your deployment tools to Jira Service Management. Finally, I'll show you how to take advantage of all of the information you have available in Jira to automate deployments based on change risk, ongoing incidents, and so much more. As we go through these, I'll show recipes to set your teams on the way to safer changes. Think about how you can use these recipes and automation to tweak or build for your own change processes as we unpack each of the tips. Before we continue, It's important to call out that every feature shown is available right now, but some service projects will not have these features available yet. To get access to these features, you can head to the Create Project screen and create a new project using the IT Service Management project template. For our first tip, we'll look at treating your software as a system. As software grows, it becomes increasingly difficult to understand how every piece relates to every other. Yet it's these relationships that are so important to assessing what is likely to be impacted by a change and how critical that is. Services are our solution to that. You can use services to lay out the distinct subsystems that comprise your software, its tier, how critical it is, who should approve a change, and more. Let's check out our first recipe. In this recipe, we're going to capture information about the system using services. We'll then use that service information to assess the risk of changes automatically. To do this, we'll combine services and automation. This first recipe is easy, so we'll dive straight in. To start, we'll define a new service in the service catalog. Here, we're going to add the orders service. This is an important service, but it's not core infrastructure like our accounts service, and so we'll make it tier 2. We'll set the ops team for the incident responders and the orders approvers group. Once created, we'll set up service dependencies. The order service depends on the account service and is used by the delivery service and notification service. Now we'll use this information to help assess the risk of change. To do this, we'll navigate to automation and create a new rule. Our risk assessment rule should trigger when an issue is created. We'll use the if block and affected services to form the condition. Using this, we can match on service tier, its name, or its dependencies. We'll use the service dependencies to check if the service is depended on by the orders service. We'll edit the issue and set the change risk to high, if so. Otherwise, we'll edit the issue and we can set the change risk to low. Now, once that's set, we'll save the rule. And we can see it in action by raising a new change request to apply changes to the account service. We'll set the affected services field to the account service, which is depended on by our orders service. You can see that the risk field has not been set. Now, when the change request is created, you can see the automation rule has checked the dependent services and inferred the change risk is high as the orders service may be impacted by that change. Let's look back at the automation rule we've configured. First, the automation rule is set to trigger on issue creation. In our condition, we assess whether the change service is depended on by our orders service. You saw that other service properties, including its tier, could also be used to inform the risk of change. You might find different aspects of services to be valuable for different use cases. You could imagine changes may be higher risk if they could impact the scalability of the orders service approaching an event such as Black Friday, and hence you may set up an automation rule to help classify such risks for these events. In this case, we're aware that the orders service may be impacted by changes to the account service, and we assess the change risk as high. Otherwise, we can assess the risk as low. Automated knowledge of these service relationships helps to accurately assess the risk of changes to downstream services. This offers a safety net for teams otherwise needing to stay on their top of their dependency statuses at all times. This brings us to our second tip, to make change visible. While understanding the system helps, it isn't enough to head off problems. To quote Donella Meadows, systems researcher and author of the book, Thinking in Systems, the bad news is that even if you understand all of the system's characteristics, you may be surprised less often, but you'll still be surprised. As changes become more and more frequent, it becomes increasingly difficult to understand what might have introduced a bug or worse, caused an incident. We know across the industry that changes are the leading cause of service disruptions. In Atlassian, when we identify a problem, teams often start by looking at dashboards surfacing all changes as a first step towards remediation. It's in these situations where having a single source of truth for every change is invaluable. In this section, we'll look at a recipe to automatically capture deployments as change requests, all from within your Jira Service Management project, and pull data from linked Jira software issues. For this recipe, we're going to connect our deployment tool to Jira Service Management in order to automatically gather details of all of our deployment changes as part of establishing a system of record for all changes. To do this, we'll use the change management capability in Jira Service Management, our deployment tool, and services. There's configuration to be done here across both Jira Service Management and our deployment tool, but it's not too difficult. Let's take a look. To get started, we'll navigate to change management settings and connect our CI/CD tool. Here we'll use Bitbucket, but a number of tools are supported. We'll use the orders service and select the connected repository from the dropdown. In the next step, we indicate that we wish to create change records for both the production and staging deployments, and we select the change request type to use. Now, let's make a change to the repository to trigger the deployment pipeline. First, it starts to build, and then it runs the deployment to staging. Once the deployment to staging is complete, we browse to Jira Service Management and see that we have a new change record for that deployment, including links to work in Jira software issues referenced in commits within that deployment. We now have deployment information coming directly into Jira as change requests. However, we have a wealth of information in the linked Jira software issues that is ideal for risk assessment. Next, we're going to use the information in these linked issues to better inform the risk of change. To do this, we'll combine Jira software, automation, and our deployment tool. We'll build some automation rules to do this, and we're going to build a very basic risk assessment rule to show the idea, but these can be as simple or sophisticated as you need. Let's see it in action. We start by editing our risk assessment rule. We'll add a new if-else block as the condition that checks the related issues using JQL. The JQL will check if we have any linked issues where the change risk was identified as critical. If so, we can infer the risk of the overall change is critical and set the change risk field appropriately. Let's look at this automation rule. We've extended our previous assess risk rule to inspect linked issues. Our condition checks the linked issues on the change request. Should any of those linked issues have a critical change risk, we'll set the overall change risk to critical. We can now include the risk assessed in the individual software issues as well as service information to assess the overall change risk. This is useful as a deployment can contain work for many different Jira software issues. Here, the risk field on the individual linked issues contributes to the overall change risk. Obviously, this is a very simple risk assessment rule, but you can express much more sophisticated rules with automation to drive change risk based on your organization's needs. We're going to look at ways of utilizing the assess risk to improve the change process in the next tip. For our final tip, we know that large changes are significantly higher risk and can be harder to resolve when faced with an incident than small changes. The final and perhaps most powerful tip today is to extend the DevOps principles of small, frequent changes through automation, but to enrich that by drawing upon the power of Jira to schedule changes intelligently. I'll show you 3 recipes here. First, we'll take control of deployments through Jira Service Management's new deployment gating capability, which is already supported in both Bitbucket Cloud and Jenkins. Then we'll introduce a standardized soak process to ensure that deployments have time to undergo sufficient testing and observation in lower environments and still go out within a predetermined change window. Finally, we'll dynamically adjust the deployment process in response to any ongoing incidents. For the first recipe in this tip, we start by pausing deployments in order to facilitate the necessary checks within Jira Service Management, where we can leverage all of the power of Jira to gather context about the underlying change. Once these checks are complete, the deployment can continue automatically. To do this, we just need to combine the change management capabilities in Jira Service Management, our deployment, and a deployment tool that supports deployment gating. As you'll see, there's not much work needed to get this set up. Let's check it out. In change management settings, we're going to enable deployment gating and select two gating statuses, one to allow a deployment and one to prevent a deployment. We'll save the changes and configure the deployment tool. We're now in the repository's environment list. We'll leave gating disabled in the staging environment, but we'll enable it for our production environment. Now we'll merge an open pull request to kick off the deployment pipeline. You can see it starts to build, and after a moment, we have a deployment to staging and a deployment production paused, gated by approval of the change request. We'll open the change request and see that the right people are able to approve it based on the service approvers group configured in our first tip. Once approved in Jira Service Management, the deployment will continue automatically in our CI/CD tool as usual. It's important to utilize lower environments, such as staging, to gather metrics and observe a software's behavior before it's deployed to production. We refer to this period as soaking. With the deployment pipeline awaiting approvals managed in Jira Service Management, we can combine this and the context we're gathering from the previous recipes to ensure changes are deployed only after an appropriate period of observation or soaking in a lower environment. We do this using Jira Service Management's SLAs. We're going to combine SLAs with automation. And there's a bit of configuration here needed across both SLAs and automation, but it's straightforward. Let's check it out. We start by heading to SLAs. First, we create a new calendar for deployments. We'll set the calendar name and define the allowed hours for deployments. The team has decided to deploy changes Monday to Friday, 9 a.m. to 3 p.m. to minimize the likelihood of problems after hours. We can also add in holidays, including annual repetitions. With the calendar created, we'll next create a new SLA. We'll name the SLA as time to soak and use a 4-hour goal in our deployment hours calendar for most changes. But for changes classified with a high or critical risk, we'll have these soak for longer to increase our confidence that they're safe to apply. And so we'll configure a goal to match on these with an 8-hour soak time. We want to start the soak timer once the change is ready for approval and finish it once the change is awaiting implementation. With the SLA configured, we'll move to automation to set up a new rule. We want to trigger this rule when the timer elapses, so we'll use SLA breach as the trigger. This rule should only apply to deployment changes pending approval, and so we'll add in the appropriate JQL as a condition. Finally, we'll set an action to approve the change request and save the rule. We've now made deployments safer by ensuring they soak in lower environments automatically by leveraging SLAs and automation. But what should we do if an incident occurs in the meantime? For our last recipe, we'll build upon the automation soak rule to suspend deployments when one of the affected services is impacted by an incident. To do this, we'll combine the change management and incident management capabilities in Jira Service Management, as well as automation and services. We'll use automation smart value and the iteration syntax in this one to build JQL. This can be a bit tricky, but don't worry, as we'll take it slowly. To do this, we'll extend our soak deployments automation rule with a new condition that searches for any issue matching JQL. Our JQL search has a few parts. It uses the automation template syntax to match on the affected service ID. It checks that the ticket is an incident and that it's not yet resolved. If there's an incident, let's add a comment that informs those involved that the change cannot currently be deployed. Otherwise, we can go ahead and approve the issue as before. Let's look back over our automation rule for scheduling deployments. We use the time to soak SLA breaching as our trigger to check whether the deployment is ready to progress. And we had an SLA configured to adjust the goal based on our change risk. The rule has two conditions. The first condition checks that the change request is a deployment and that it's pending approval. The second searches for any open incident for services that will be affected by the change. The match on the affected services field uses automation smart values to get the affected services from our triggering issue, and we use this to build a list of service IDs in the JQL. In the JQL, we also have constraints for the ticket category and status category fields to narrow the results down to only the incidents that are not done. With knowledge about whether we have any related open incidents, we can now take action. If we have incidents open, we can just add a comment to the issue advising that the automated deployment has been suspended due to ongoing incidents. Otherwise, we use automation to approve the request and in doing so, automatically resume the deployment. We do this safe in the knowledge that we've assessed the risk, soaked the changes appropriately, and ensured that there aren't incidents open for the affected services at the time of the deployment. Okay, let's recap. First, we've looked at how we can leverage services to capture knowledge about how our software fits together and how to use that information within automation to assess the risk of change. Then we looked at how we can integrate deployment tools to automatically capture software changes, including how we can use the information in Jira software issues to further enhance the knowledge about a change. Finally, we looked at how we can leverage this knowledge to control the deployment and then build upon this to automatically deploy changes according to the risk of change. This includes halting an automated deployment in the event of an impacting incident. Throughout these tips, we've showcased how you might leverage Jira Service Management to enhance your existing deployment process by allowing change risk to be both determined and acted upon automatically. I encourage you to incorporate these ideas into your own software change process, making it both safer and faster. My team is really excited about these capabilities. We look forward to hearing how you take these ideas and use them to improve your own change processes. We'd love to hear from you input and ideas, which you can submit to us using the Give Feedback button in your service project side navigation. Also, if you have any questions about this talk, head over to the linked Q&A post in my speaker resources. Together, we'll create the future of change. Thank you.